From Informa Tech Target, I'm David Essex, and this is Enterprise Apps Unpacked. Physical AI is a newish term for making older technologies like industrial automation and the Internet of Things more intelligent and data-rich with artificial intelligence. Physical AI combines AI with technology that can interact with the environment, especially sensors that can measure things like location, temperature, or humidity, and actuators that convert energy into motion in response to signals. It's the AI behind factory robots, drones, and self-driving cars. Gaining a degree of intelligence from physical AI means machines can act independently and learn from their own actions and the data they pull in from their environment. You can see why physical AI, which is sometimes called embodied AI, is increasingly important in the broader AI trend, especially agentic AI, which has similar characteristics of independence and learning, but in environments that are purely digital, like an ERP system. Today's guest, Yad Oren, leads work on this and other leading-edge technologies for SAP as Managing Director of SAP Labs US and Global Head of Research and Innovation at the company. What does SAP have to do with physical AI? Though it started as and remains best known as an ERP vendor, it has moved into AI in a big way, including most recently agentic AI and the data technologies needed to feed AI models the information they need to discover things, learn, and act. And it turns out that enterprise applications, including ERP, often go hand in hand with physical AI. In fact, Yad believes software is the reason 2026 will be the year physical AI moves from pilots into core business operations. In the podcast, he makes the case for software's centrality in physical AI and what SAP brings to the equation, including some of the work going on at SAP Labs. We also talked about the opportunities, risks, and challenges of implementing physical AI and the business operations that will be most affected. Don't forget to rate, review, and subscribe to Enterprise Apps Unpacked for the real story on the software that runs your business. Yad, it's good to see you again. It's been a few years since we met at Sapphire.
Yes, David. Great being here again.
So you are managing editor of SAP Labs US and the global head of research and innovation at the company. What roles do those two organizations play inside SAP, but also with SAP customers?
Yeah, so as the head of research and innovation, we are looking into emerging technologies, anything that can help our customers in 5 and 10 years horizon, kind of inventing the future of IT and business reality for our customers. And of course, we're talking about a lot of research, prototyping, fast-moving development. And this is a global organization. We have quite a few locations. But as my second role as the managing director of SAP Labs US, I'm also highly connected to the local ecosystem, the academia, startups, the technology partners. And this, of course, creates a wonderful synergy because it allows us to tap better into the main innovation we are doing here in Silicon Valley and beyond, and kind of have everything we're seeing here inform innovation worldwide.
Can you give a recent example or two of a technology or a product that went from the SAP Labs to actual deployment and commercial availability?
Yeah, so one of the projects that we are very proud of is Joule for Consultants that was released around a year and a half ago. And if you know about Joule, is our AI offering from SAP, and Joule for Consultants is how you have dozens of certified consultants in your fingertips to help you perform tasks that usually require much more time and expertise. And this was a great innovation started around 3 to 4 years ago, where emerging technologies like large context windows was still something new. I know today is a commodity, but back then we were able to work with partners like Anthropic and others to really harness this kind of technology and make the LLM learn really large corpus of information, have the right RAG and semantic understanding to bring back distilled information of very complex certification. So this product was built here and started as incubation, and then today is one of the best adopted AI offering from SAP.
So our topic today is actually the opportunity in physical AI. So first, for the listeners, can you explain just what physical AI is?
Yeah, so physical AI is a branch of artificial intelligence, and it enables machine to perceive and understand and interact with the physical world. And this is maybe the big difference between generative AI and other regular AI terms we're hearing today, because it's covered the gap. It's bridged the gap between the digital intelligence we're all familiar with, solution like Joule, ChatGPT, and more of those, to the material world, and allowing robots eventually, or vehicle, or any autonomous assets to work at scale with the intelligence that we are seeing today in the digital world.
So I think people have become quite familiar with generative AI, especially since it's the one that you communicate most directly with them. But then also agentic AI has come along, and it's a big focus of ERP vendors and all sorts of companies. So how does the AI used in this physical context differ, if it differs at all, from those other kinds of AI that maybe the general public is more familiar with?
Yeah. So how much time do we have? Now, this is a great question. And I can divide it into two elements. First of all, there is the application of generative AI, as I think most of us familiar with. And this is the AI being applied to the physical world. The other topic, which I will talk about momentarily, is kind of new application we don't really used to see in the regular generative AI we see in the digital world. So of course, when we talk about the first point, when we are applying current LLM technology to physical AI, it's about having the robot having a brain, if you will, that enable to learn the tasks that they perceive and able to understand context. And if now, let's say, a field technician asks from a robot, can you pick and place this kind of item? They know to interpretate this task and conduct it. Just like you talk with a prompt and get answer today from LLM, you can talk or prompt into a robot and enable them to provide enterprise task. So it's about the understanding of the task and also increasing the reach of what robot can do, the understanding, the perception, and so forth. The second part, beside applying what we're seeing today in the digital world to the physical world, there are new era that needs to come into place. And of course, when we are talking about physical AI, if I just cover 2 points very quickly, the entire perception of the environment, understanding what we call the world model, vision and perception, where I'm located, and how I can move better and optimize my route. Everything regarding vision recognition now becoming even more important. And we see generative AI help with this as well, using different technologies from LiDAR and LLM to understand the different environment. This help the robot to have a better understanding and perception of how they can operate in warehouses and so forth. And the last point around this new notion, now that we are talking about physical entity, there is a lot of work we need to do about safety and reliability. So geofencing, be applying AI to have better security and physical security. You don't want a robotic arm to slap any employee face. Those also being applied as kind of a new use of AI in the physical world. So if I summarize, we have the AI as we know it from the LLM and digital worlds used in the physical AI to enable this kind of interaction, understanding of task and human-machine interface. And the second one, new topic like perception of the vision and environment that we don't see in the digital world, together with some safety and reliability that are a new application of generative AI into the physical world.
I understand that you believe software is the reason 2026 will be the year physical AI moves from pilots into core business operations. Can you elaborate on that point? Because that's very interesting. For one thing, which business operations and why this year in particular?
Yeah, so there are so much demand we're seeing already in physical AI. And I don't want to spill the beans, but stay tuned for our annual conference at Sapphire for many interesting customer use cases. But where we are seeing demand mostly at the moment is around enterprise warehouse management, use case like pick and place and detecting, a defected item and good. And we have many customers that we are seeing already and publicly expressed their show the work with us, like Bitzer, who is show supply chain efficiency and enterprise warehouse management, and other companies. And this is one element. We also saw a lot of need for inspection use case. Now you have the robot looking into different pipes and equipment, know if there is from thermal vision, they know if there is a certain leakage, and they can understand risk and where we need to do maintenance. So everything regarding field technician and inspection is also very, very important. And everything regarding operation in big warehouse and how you can really help in commerce as well to provide the good, to replenish is another big use case that we are seeing. But we are seeing massive demands across different line of businesses. And it's very important, David, to double down because, of course, the software is a huge breakthrough. And LLM, generative AI has been in research since 2018. I think the world understands the true power of this in 2022 when ChatGPT version 2 came. But now we are seeing the breakthrough from software perspective with physical AI. Important to put a footnote, of course, when we talk about robotic, many other non-functional elements like regulation, workforce upskilling, and so forth. But you're absolutely right that from software, we are seeing 3 disruption, which make it different, because it's also very important to recognize that robotic has been in our industry for 4 decades already. I don't think if you go to a modern warehouse today or automotive manufacturing, you probably see many robots walking between the racks or activate and manufacture the goods. The disruption, the step change that we are seeing thanks to the software falls into 3 points. First of all, thanks to the LLM, you can understand and upload many more tasks that you are doing. Most of the robots we have today, I don't want to overgeneralize, but of previous decades, are like one-trick pony. You can do very good one activity with a robotic arm, cannot really understand what to do if something goes wrong, cannot have a reasoning that we are knowing very well from AI agent today. And today, the first point that we are seeing with the software is that you can do many more tasks and many more, you can have a bigger brain for the robot, if you will, that we weren't there before. And then it can, just like we see with AI, it's start to do bigger and bigger part of the potential workload you're asking them to do, not only one-trick pony. The second topic, which is very interesting, and we learned it a lot from element like the reinforcement learning breakthrough and what we learned from DeepSeek, you can do much more with less. From the computation that you need to put on to serve the LLM, you can do smaller models that are very relevant when you're talking about physical AI. You can put much more information on the smaller brain if I combine the first one and the second point. So we did not only learn that you can do and upload many more tasks with the generative AI, you can also do it with much less power and computation. And the third thing that enables us with the recent progress around agent orchestration, also robotic now are much better in coordinate between themselves, which is very important because eventually we are talking about robotic at scale. We're not there yet that we are seeing fleets of robots everywhere. Maybe in certain areas like China, you can see this already, but most of the world is not there at scale. And the third point that software really helps us is about the orchestration and coordination between robots. Because it's fun as it sounds, if let's say, David, you and I are robots and we are getting a command, can you bring this screwdriver from point A to point B? Today, I will just go and bring it. But in today reality, I can perceive, hey, David is pretty much closer there, and I can delegate to you this task, just like we see with the agents today, it's software. And this coordination and orchestration, I really simplified at the moment, also went like miles ahead. So if I summarize, the software progress is around being able to do much more tasks before, being able to do it with less compute like we had in early days of LLM. And the last one is also everything regarding the coordination, syndication, and collaboration between robotics and human became much more advanced thanks to agent orchestration and so forth.
Mm-hmm. So what's the opportunity here, especially from like the customer and the end user perspective, and also in the context of enterprise applications, which is, usually the main focus of this podcast? Why do it, in other words?
So I think to put things in perspective, I think we're still having a couple of years until robotics will be at scale in manufacturing and others. There are many other points that we discuss. Also, currently, most of the robotic around the world, the price point is still very relatively high. We keep hearing from companies like Tesla and other the great promise for big robotics, but this will get there in the next 3 years. What I will encourage everyone at the moment, and this is very actionable, to start having both opinion on how this reality look like, because we are seeing a lot of progress with C-level executive imagine how the future workforce will look like between human and agents. But now you can have these triads of human agent and also physical AI. So not to be too philosophical, but I think that in 5 to 10 years, let's say, David, you are now a manager in R&D team in some automotive industry or oil and gas. Probably today you will have a reporting line of humans. Soon enough, you will have humans and agents. You might have human agent and robots reporting to you. So I just want people to start being cognizant that this scenario might come and start thinking what's important for the business. But the more important point, the second point, there are now new offering that in beta, like from SAP, that you can start exploring or co-innovation we can do. I don't think customers need to go with a big bang, but if you think that there is efficiency in business value, in enterprise warehouse management, field technicians, monitoring and inspection, find the fact. If you know now that you imagine this reality and when robotics can bring value to you, de-risk you, reduce risk, reduce costs, increase your productivity, you can start engaging as pilot. And this is what we see from many customers. I mentioned Bitzer. We can also mention Matur Fumak from Turkey. They are building automotive seating systems. Those customers and many more customers we're going to show at SAP are starting to proof of concept this concept and spilling the bean a little bit. They're super happy from the ROI they're getting. So start imagining this reality and having an opinion, learn what we do. We also collaborate a lot with NVIDIA. Now is the week of JDC and with other robotic vendors in order to bring this reality. And once you have some scenario planning, feel free to reach us and we can start proof of concept. We can start small. We have teams like my team and others that help to do this, but it's very important that customers would at least try, because if this reality comes, you don't want to be left behind.
You've given a bit of the history of where this has existed, robotics in general, in industrial automation. Tesla's a prominent example, has a highly automated assembly lines, but they also have self-driving cars that are under development. So given the kinds of companies that are very high profile in robotics and physical AI, why should people pay attention to what SAP is doing in physical AI? What does it bring to the party?
Yeah, and I think it's a very important, maybe naive clarification, but I think most of your audience know it. SAP does not build robots. We are a software company. But your question is super important because I would argue that equally important for enterprise than having the physical device, or even more than that, is the software layer that know how to orchestrate and onboard enterprise tasks and scale for the different robots. Because first of all, when we talk about the physical AI reality, and if we now imagine 3, 5, 10 years from now, and you're going to have not only this one-track pony robots, but you're going to have much more line of business augmented and collaborate with human, then you're probably going to have multiple vendors. And you want to reach a situation that you know how to say, hey, dear robot fleet, please pick this material from this bin, sort it, understand if there is malfunction, and put it in this rack or so forth. In order for this, you need a layer that know how to abstract it, the software that know how to onboard and decipher each robot way they look at the item and how they treat each one of the business tasks. In addition, you also want to be very, very careful with all the auditing and reporting back. Eventually, you want to manage this fleet of robots. We have solution today, but we are talking about, again, a bigger reality when you could do more. And also robotic can learn themselves much more by themselves. And this is where you need also all the guardrail, the business auditing, the governance around them, which is also important in the software. And the SAP is focusing on those two ocean of opportunity. First of all, to have the layer that knows how to onboard all the physical AI to be extension of the different line of business. They're going to be different vendors, different line of business tasks. Some of them come from, we also have a great use case, by the way, for health and sustainability, how you can also make sure there is no hazard in the workplace and so forth. My point is you're going to have many line of businesses. You need a software layer that's going to abstract it and make sure you can seamlessly, like you talk to human, like you talk today to any model, LLM of your choice, to onboard the robot and communicate with them. But also you need to make sure everything is enterprise ready. And there are so many, I would say, hazard over there, not only physical hazard, but if the robot needs to complete a task, they need to make sure you have the right analytics, and health score of different robots are different, how you know how you manage the fleet. This is why you need this software to make sure eventually physical AI is true extension of your enterprise applications.
Nice segue into the other layer about specifically enterprise applications, the ones that end users interact with the most. And so ERP, was SAP's original business going back over 50 years. Where does all this fit in, and what's going to happen with physical AI? How does it sort of bubble up into the ERP system that people use?
So we keep being surprised from the amount of customer use case we are getting. And this is why, together with our ecosystem, we have a wonderful list of partners as well, also on robotic vendors that we are working with. We identified many line of business and many ERP ramification, if you will, that can be augmented by robotics. The biggest demand we're seeing at the moment is everything regarding the logistic, the warehouse management, make sure you can optimize your warehouse with the bigger efficiency. And this breakdown, if we spend a few seconds on this, to many ERP tasks, which are very familiar, many transactions that are familiar probably for our audience, from pick and place or inspection, or even reporting that a good was received, all the way to the work for field technicians and how you can now do the assets and the inspection. At the moment, pretty much any task we're seeing in the warehouse, and I will also add manufacturing to that because it's a big portion of the ERP. Here we're seeing many augmentation of what we have today with robotic as well in manufacturing, back to the fact that robots can really do much more tasks. Not to derail, but just to mention another very important point that is another breakthrough that falls into robotic today and might also help the audience understand what's so new about robotics, is that the learning to learn a new task for robotics is becoming very minimal, almost to zero. I can recommend this online YouTube video from Figure AI, a robotic company from the US that showed the robot like a banana. It never saw this fruit, and it recognized it's a fruit and knows how to put it in the fruit bin, although it was never trained on this kind of thing. So also in manufacturing, understanding new tasks you need to do, self-correction. We're seeing this across almost any aspect of the ERP, but if I need to pick one of them, where we see the biggest demand is anything regarding managing warehouses, from the receive of goods to inspect them, maintenance, all the way to the deployment and put them on the shipments for our customers. And maybe just to end up also, you mentioned Tesla and others. Even in autonomous vehicle, we have supply chain management scenarios. We also hear demand for this, which also touch with autonomous vehicles. We don't have yet customer proof of concept in this front, but the sky is the limit for what kind of use case and proof of concept you can do with physical AI.
So what are 2 or 3 of the biggest things that people should be ready for and aware of as they're preparing for physical AI and the process of actually trying to implement it?
It needs to be part of your enterprise application story. It's very important because now we're seeing a proliferation of very good solutions that are aiming for one task, which is great. You have robotics for manufacturing that can do only welding, or robotic in commerce that can do only shelf replenishment, and others solutions that are mentioned to this. The perfect reality, in my opinion, is a seamless extension of your business suite, of your enterprise application stack. And customers should be aware that you need a very strong software layer, and what we call the flywheel effect also in physical AI. Because I keep hearing the flywheel effect, which means that you have great application with AI, then you use them, so you generate more data. Then with a strong data platform, you can store the data and understand this, and then you can create another stronger AI model. So application create more data being analyzed to create more AI, and it's go back to the application to improve them. The point is, this model is very known and appreciated in the digital AI world. When you have the software, it's the same in the physical AI as well. Eventually, the robot is extension of the human brain, of the human of the application we have already, if you will, and this needs to be connected to application. The software layer that you need to do there to collect the data and analyze this is also relevant for physical AI, analytic use case and error correction and others. And then you can generate even better physical intelligence as well for improving the vision recognition or improving the current task. And this is something that's very important for customer to think about, how this flywheel effect work already also in physical AI. Because if I finish this with the first point I mentioned in this podcast, eventually physical AI is a branch of artificial intelligence, has the same flywheel needed in order to create great business out.
What are the biggest risks that companies should be prepared to address? And maybe this comes up in the governance process.
Yeah, so we can divide it into maybe more functional risks, and then risks that go beyond the actual offering itself, like compliance and regulation and others. But when we talk about the risk with the robotic offering itself, there are 2 things that comes to mind. First of all, physical AI offers a new type of defense and security consideration you haven't done before. One of them is the physical security, because now we have a moving object, and it's bring many terms into our world, like geofencing and others. You don't want the robot to run, and also the same security concept we know for software apply, like data privacy, roles, and others. Theoretically, that you can have option when you have a robotic colleague, right, that works with you. And now you need to decide, does this robot from data privacy perspective can recognize my face, have image recognition, can access this kind of data or not? So there are physical consideration you need to take place. And of course, there's a solution for this, and everything is already baked into the offering and how SAP plan on this. But this is a new thing people need to think about it that we don't encounter in the software world. And the other thing, it's another entity that you need to give permission to understand from data privacy and other security and encryption, just like you deal with any other software component, another edge point you want to address. So this is in the functional area and some of the risk you need to know. The other one, I'm going to keep it very short. Of course, if you are now choose to try the embodied AI, the physical AI offering, highly recommend to understand that you have the right skill set in your organization. Sometimes people might talk about, hey, robotics and loss of job, but actually many of the counter things is relevant as well. You need many skills to help the robotic, to train them, to make them work. And this creates a lot of skills needed sometimes to make sure you can bring this new function to your organization. And yeah, and of course, regulation, just like we're seeing a lot of bills and warrant around digital AI, we need to stay tuned what will be the opinion of this government or another regarding physical AI. And this is, I wouldn't see it as a risk, but something to be aware of. But the biggest risk, and I finish with this, David, is of course, the lack of thinking about this and not imagining what kind of business value you can bring from that, right? Because I come from engineering, but I see the business value our customers already doing with this proof of concept. And it's really, it's mind blowing. So I think the biggest risk is honestly do nothing. And I go back to my call for action with the 2 points we mentioned earlier. Try to imagine scenarios when you see a strong business outcome, and you can engage in beta services for proof of concept to make sure you at least try this. And we are here to help.
Much of the technology involved in physical AI sounds familiar to me anyway as building blocks of the Internet of Things, and sensors is one of them, and of course the Internet. And IoT itself went through the usual hype cycle. I don't know if it actually went through a trough of disillusionment, to use, I think, the Gartner phrase, but it was really talked about, a lot of hype, and then the implementations weren't there. But over time, my impression anyway is that IoT has had some real deployments, and sometimes it's not actually called that, but it's effectively Internet of Things used in industrial automation and in sustainability and all that kind of thing. So my question really is, what does physical AI do to the IoT equation?
I think you can draw a line between IoT and physical AI, like you can draw a line between the previous generation of AI, narrow AI, like 12, 13 years ago. I used to be a developer in this area of when regression and classification and clusters and convolutional network were there. It's a very good offering, but it never unlocked this big potential like we see today. And we didn't see any, OpenAI, Anthropic coming out of this previous generation. And the same, you can draw the line between narrow AI and generative AI to IoT and physical AI today. Because like we said earlier, there are much more capabilities you can do with this current disruption we are seeing. And I mentioned the fact that compute on the edge now is becoming much bigger, but also the efficiency to run huge LLMs or, using this reinforcement learning and others, another thing that we learned in recent years, you can just put a huge brain, not just this one or two activities that IoT can do usually. You could per device, you could do much more with lower compute. So there is a lot of progress, and I think this takes us a giant leap into productivity and what can be done. And beside the IoT, also something that SAP is not doing, but there is a lot of progress in the robot themselves, the humanoid and others. If you see companies like Gira, Boston Dynamics, Aptronic, others, what they did with building device itself and how it can really mimic as much as possible human behavior and do many more activities. Both the software progress I just mentioned and the hardware process took this IoT that was pretty limited. And I think it was overhyped. I also remember like 30 trillion market cap analysis, but 10 times bigger than the US GDP and other. I think now we're seeing much more business value coming out of this in early stages.
So maybe you've already mentioned these examples, but because you just mentioned something, I think, involving, I don't know if it's Boston Scientific or Boston Dynamics. Yeah. But are there examples of physical AI that SAP Labs itself is working on? And can you tell us about any of them and where they stand in terms of becoming products?
So it's a great time to ask this question because at SAP our annual conference in Orlando, in the second week of May, we planned to announce a certain offering regarding robotics. Cannot tell the exact details, but to answer your question, the main areas when we're going to focus in the showcase is around supply chain management efficiency with the enterprise warehouse management, support for some field technicians, and everything regarding activities like pick and place, inspection, quality controls, and things like that. So I think stay tuned for more news around how you can drive digital supply chain, especially around warehouse operation coming at SAP, and many more examples that we're going to scale coming already this year. So this is the best I can tell you, but happy to share more when SAP is coming.
Well, I'll be there. So again, Yad, it's been great to see you again, and I appreciate your coming on the podcast.
My pleasure. Thank you so much, and looking forward to see you again soon.
Thank you for listening to Enterprise Apps Unpacked, where we give the real story on the software that runs your business. To learn more about business applications, explore our content on searcherp.com. Find us on YouTube at our channel, Ion Tech. Subscribe to our podcast to receive the latest episodes as they drop. And if you liked what you heard today, give us a rating and review on Apple, Spotify, or wherever you're listening. Until next time.
Podcast programming and promotion by Kelsey Waddell. Podcast production and quality oversight by Anne Steshu. Music supplied by DP via Getty Images. This is an Informa Tech Target production.